This is another assignment for the data science using chatbot AI. So this is the project of mine, like where like I'll be generating anime face generation like using the GANs. So this is the overall project. I'll explain the step by step. But before this, I have just traveled on the how ChatGPT can write the end-to-end code and other things. So here is one example demo where just give the data set and the prompt to it, and it can able to generate the entire code, and it can transform that to the collab file. So it's able to do it everything. So here is the example code and everything. From here, we can get the collab link as well. So this link open up the collab file of this. So here I have fine-tuned a little bit. The basic ChatGPT one was pretty decent. I have added some more comments to it, and I have fine-tuned a few of the things over on the top of that. To begin with, the basically the title for this is anime face generation using GANs. The main objective is to build and train a generative adversarial network. That means GANs that generates a faces by default, like either anime faces or human faces based upon our requirement. We can fine tune the objective of this we are using GANs, just want to try how it will be in the long run and other things. And this will operate the evaluating model performance using the matrix FID and other things. So the main component of the GANs is producing fake images from the random noises. So and that's the main part of the generator. And another one is a discriminator. uh, what this discriminator does is differentiates the mm, reality and fake images differences. So that's the main task of the discriminator, and the generator is a one which generates anime face from the random noises. And this will be the workflow. The generator creates images from the latest space, and the discriminator evaluates whether the image is real or fake. So both these components again is the each other with a zero sum game. So at the same time these both will tackle, and it will permit their results. That's what means zero sum game means. And for installing, we need to install the PyTorch Vision and the Pillow and Torch Vision FT. And for data sets, like I'm using anime face generation, a data set that's in the Kaggle. This is the data set I used. It consists of a 414 MB, and it has all the files, and I have read the files via local, and I have unzipped the file. So once the unzip the file is done, then we need to define the uh, data pre-processing step, like where I'll be changing my GPU to the CUDA GPU to use that. And we use anime face images to data set to load and pre-process the data. So once the pre-processing the data is done, then we go to the defining generators and the discriminators. So generator converts the latest noise into the realistic looking anime faces, and the layers would be converse transport 2D and the batch norm and the relay activations and other hand scalings. But for a discriminator model, we use a classifier real versus image of fake one. And these are the discriminator and the generator ones. And for the loss function, we can define it as a binary cross entropy loss, that is BCE loss function for the both the generators and the discriminator. So once the loss function is done, then the training the GANs will begin. For the training process, alternative training between discriminator and generator will be done, and discriminator tries to maximize the accuracy in distinguishing the real and fake images, and the generator tries to minimize the loss of generating realistic images. So key output for this will be the loss value and the saved generation images at the different approaches for visualization. So this is the example of it. And next comes the evaluating with a FDE. So here is the 50 generated approaches for our file, and those 50 will be the 50 different images. By combining all of them, I'll create a video for that. And then the evaluating model with a FID. So FID is a matrix used to quantify the quality of generated images by comparing the distance between featured distribution of real and generated images. So code snippet will be realizing images into interception v3 input size and calculating a FID score. And the next part will be visualization generic images. So here is a visualization generic images. So in here shows the generated anime faces using the training generator model and compare across each of the images to see the program image quality. And once that's done, then here with the help of OpenCV and O2, from the generated 50 random images, it will create a video of that. And as a conclusion summary, the success implementation of the training of GANs and generated images are the style, and the evaluation performance using the FID score, and we visualize results using the images and video of a process of our training models. So here is example of this generated models, where by default all the approaches will be generated, and uh, by the discriminator, like we change the generated into the valid realistic anime faces. So this is all about the project, and the whole project is generated using the chat gpt, and later the video part by the combining and everything, like I have gave the code here to do that. And here is the example of the final results of the anime face generator and detector thing. So by default this is the starting quality, and it has automatically by the zero code zero sum game, it fine tuned into the real examples and perform the model. So this is about the one thing, and yeah.